Picture yourself standing on an open Ice Age plain. The wind cuts through the frozen grass, carrying the smell of snow and damp earth. Then the ground begins to shake. At first, it's almost imperceptible, but within seconds, the rhythm becomes unmistakable. Something enormous is moving toward you. Over the next rise appears a woolly mammoth, towering nearly 13 feet at the shoulder and weighing as much as 9 tons. Its curved tusks stretch several feet in front of its body, each one capable of tossing a grown human through the air with ease. Thick layers of muscle, fat, and shaggy fur protect it from predators that would never dare attack such a giant. Now imagine what stands in its path. Not another mammoth, not a pride of massive Ice Age lions. A human. No claws, no fangs, no thick hide, no natural armor. Barely reaching the mammoth's knee, armed with little more than a sharpened spear and a mind that, at first glance, seems like a poor substitute for raw strength. If you judged this encounter purely by anatomy, it wouldn't even qualify as a contest. It would look like a fatal mistake. And yet archaeology tells a completely different story. Across Europe, Asia, and the Americas, researchers have uncovered mammoth skeletons bearing unmistakable stone tool marks, embedded spear points, and carefully butchered bones. The same evidence appears alongside mastodons, giant bison, ancient horses, and other Ice Age giants. These weren't isolated strokes of luck or desperate scavenging opportunities. For hundreds of thousands of years, humans repeatedly hunted some of the largest and most dangerous land animals that have ever lived. How could a physically fragile primate accomplish something that seems almost impossible? The answer has surprisingly little to do with stronger weapons. Instead, it begins with a way of thinking unlike anything else in the natural world. Long before cities, agriculture, or even written language existed, our ancestors had already learned to turn physics into a weapon, landscapes into traps, and cooperation into a force powerful enough to overcome animals that outweighed them by 100 times. That discovery would change not only the fate of the mammoth, but the future of humanity itself. The remarkable part is that none of this appeared suddenly. There was no single moment when humans woke up and discovered how to hunt giant animals. The roots of these extraordinary hunts stretch back far deeper into prehistory than most people realize, to a time when our own species had barely begun to emerge and Europe was home to another kind of human entirely. In northern Germany, at a site known as Schöningen, archaeologists uncovered a collection of wooden spears unlike anything anyone expected to find preserved. Recent dating places them between 200,000 and 300,000 years old, making them among the oldest confirmed hunting weapons ever discovered. They aren't crude branches sharpened in haste. Each spear was carefully carved from spruce or pine, balanced with remarkable precision, and shaped in a way that suggests their makers understood how weight distribution affected accuracy and power. Even without metal tools, they were engineering sophisticated weapons. The surrounding evidence is even more revealing. Scattered among the spears were the butchered remains of more than 50 horses. Cut marks on the bones show the animals weren't scavenged after dying naturally. They were deliberately hunted, processed, and consumed. More importantly, this wasn't the aftermath of a single lucky day. The repeated layers of remains indicate hunters returned to the same lakeshore over and over again, using it as a reliable hunting ground across many seasons. Researchers noticed another intriguing pattern. The hunters didn't attack horses at random. They consistently targeted family groups instead of bachelor herds. That seemingly small detail reveals something profound. It means these ancient humans had spent enough time watching their prey to understand its social behavior. They recognized which groups were more vulnerable, anticipated how they would react under pressure, and built their hunting plans around that knowledge. The hunters responsible were almost certainly Neanderthals or closely related human relatives, people often portrayed as primitive brutes. Yet the evidence paints a completely different picture. They observed, planned, cooperated, and returned to successful locations again and again. Long before agriculture, permanent settlements, or written language, humans were already conducting organized, repeatable hunting operations that relied on intelligence rather than brute force. That raises an even bigger question. If humans were already planning hunts hundreds of thousands of years ago, what actually made those hunts successful against animals hundreds of times their size? For decades, popular culture has shown prehistoric hunters defeating mammoths in almost exactly the same way. A circle of people surrounds the animal, raises their spears, and throws them one after another until the exhausted giant finally collapses. It's a dramatic image, and it appears in countless documentaries, films, and illustrations. There's just one problem. The physics don't work. A woolly mammoth wasn't simply a large elephant, it was an animal protected by an extraordinarily thick hide, dense layers of muscle and fat, and a skeleton built to support nearly 9 tons of weight. Even the strongest modern athlete can only generate so much force with a thrown spear. Against an animal of that size, the impact would be surprisingly disappointing. Instead of driving deep into vital organs, many thrown spears would have struggled to penetrate far enough to cause a fatal injury. In other words, if Ice Age hunters had relied solely on throwing their weapons, they probably wouldn't have survived long enough to perfect the technique. That realization led researchers to rethink one of archaeology's most famous artifacts, the beautifully crafted Clovis spear points found across North America, many discovered alongside the remains of mammoths and mastodons. For years, these elegant stone points were assumed to be the tips of javelins launched from a safe distance. But in 2024, researchers at UC Berkeley proposed a very different explanation, one that completely changes how we imagine these hunts. Instead of throwing the weapon, hunters may have planted it. Their research suggests that many Clovis-tipped spears functioned more like heavy pikes. Rather than charging toward the mammoth, the hunter braced the butt of the spear firmly against the ground, angled the stone point upward, and waited. The goal wasn't to overpower the animal. It was to persuade the animal to overpower itself. Imagine a mammoth charging with several tons of momentum behind it. Every step adds tremendous force, far more than any human arm could ever produce. When that mass collides with a firmly planted spear, the mammoth's own body drives the point deep into its flesh. The hunter contributes almost none of the killing force. Gravity, momentum, and the animal's own speed do nearly all the work. The Berkeley team's experiments demonstrated just how devastating this could be. As the stone point pierced the target, the wooden shaft behind it could splinter and widen the wound, producing damage far greater than the initial puncture alone. The researchers compared the mechanism to the way a modern hollow-point bullet creates catastrophic internal injuries, not because the projectile is especially powerful by itself, but because of what happens after impact. It's an astonishing inversion of expectations. Humans didn't defeat Ice Age giants by becoming stronger than they were. They won by understanding something far more valuable: the rules governing motion itself. Instead of matching a mammoth's strength, they redirected it. Instead of fighting against physics, they recruited physics as an ally. That may be the most important breakthrough our ancestors ever made. Once you realize you can make an opponent's greatest advantage become its greatest vulnerability, size stops being an unbeatable defense. But even the perfect weapon is useless unless you can make a mammoth run exactly where you want it. After realizing a mammoth's greatest weakness wasn't its body but its momentum, humans reached another conclusion. They didn't always need a weapon in their hands. Sometimes the landscape provided one. Ice Age hunters knew their surroundings with an intimacy that's difficult to imagine today. They understood where migrating herds crossed rivers, where valleys narrowed into bottlenecks, and where seemingly gentle terrain suddenly ended in steep cliffs. These features weren't simply landmarks. They were opportunities. Instead of confronting a herd head-on, groups of hunters spread out across the landscape, each person playing a carefully planned role. Some remained hidden near natural choke points, while others gradually pressured the animals from behind. There was no frantic chase. The objective was to guide the herd, almost imperceptibly at first, until the terrain itself limited every possible escape route. A narrow canyon compressed dozens of massive animals into a confined space where panic spread rapidly from one individual to the next. A box canyon transformed a powerful herd into a trapped one. A cliff edge, invisible until the last moments of a stampede, became the final obstacle. At that point, the hunters no longer needed to overpower creatures weighing several tons. Gravity took over. Archaeological sites across multiple continents preserve evidence of these communal hunting strategies. Dense accumulations of butchered animal bones near natural bottlenecks, ravines, and cliff bases suggest that prehistoric hunters repeatedly exploited the same geographic features over generations. Some individual sites remain the subject of scientific debate, But the broader pattern is remarkably consistent. Wherever the landscape offered a natural advantage, humans learned how to turn it into part of the hunt. What makes these discoveries so remarkable is that they reveal a level of planning extending far beyond the moment of the kill. Success depended on reading animal behavior, understanding seasonal migrations, coordinating dozens of people, and choosing terrain where the environment would do much of the dangerous work. Once again, intelligence replaced brute force. Humans weren't defeating mammoths because they had become stronger predators. They were becoming better strategists. Eventually, however, even nature's own traps weren't enough. Rather than waiting for the perfect landscape to present itself, humans took the next extraordinary step. They began building landscapes designed to hunt for them. In 2019, archaeologists investigating a site that would eventually become part of a new airport uncovered enormous pits deliberately dug by ancient hunter-gatherers nearly 14,700 years ago. The evidence pointed to a remarkable conclusion. These weren't storage holes, shelters, or accidental depressions. They were carefully constructed traps designed specifically to capture woolly mammoths. Digging one of these pits would have required an enormous investment of labor. Without metal tools or draft animals, every layer of earth had to be removed by hand using stone, bone, and wood. The effort only makes sense if the hunters expected the trap to pay dividends long into the future. That is exactly what the archaeological evidence suggests. Rather than abandoning the pits after a successful hunt, generation after generation returned to the same location. They repaired damaged walls, maintained the surrounding landscape, and preserved the knowledge needed to use the traps effectively. Researchers estimate that some of these hunting pits remained in continuous use for more than 500 years. Pause for a moment and consider what that really means. No single hunter could have witnessed the entire history of those traps. The people who first dug them had been gone for centuries before the last mammoth was guided toward them. The knowledge survived because parents taught children, experienced hunters instructed younger ones, and each generation inherited not only the physical structure, but the accumulated wisdom of everyone who had come before. Where to position the hunters? Which migration routes were most reliable? What season offered the greatest chance of success? The trap itself became a monument to collective memory. This discovery forces us to rethink what prehistoric hunting actually looked like. These weren't isolated bands improvising from one day to the next. They were investing in infrastructure, planning decades ahead, and preserving specialized knowledge across lifetimes. In many ways, these hunting grounds functioned like the long-term projects of later civilizations, except they existed thousands of years before farming or permanent cities. Perhaps the most moving detail came after the hunt was over. Archaeologists found mammoth tusks and massive shoulder blades deliberately arranged around skulls in careful patterns. These weren't the random remains of butchery. They appear to reflect intentional acts, suggesting ritual, gratitude, or respect for the animals that had sustained these communities for generations. There is something profoundly human in that contradiction. The same people who engineered sophisticated systems to trap and kill mammoths also seem to have recognized that their survival depended on them. They exploited these giants with extraordinary efficiency, yet they may have honored them with equal sincerity. Even at the height of humanity's growing mastery over nature, there remained an understanding that taking a life, especially one so immense, deserved remembrance rather than celebration alone. Beyond carefully constructed traps and a deep understanding of the landscape, ancient hunters had one more advantage that seems almost absurd when compared with the size of their prey. They could simply keep going long after most other animals had to stop. Humans are not the fastest runners on Earth. A horse, a deer, or even an elephant can easily outrun us over a short distance. But hunting isn't always decided by speed. Sometimes it's decided by endurance. Unlike almost every other large mammal, humans cool themselves by sweating across nearly the entire surface of the body. As sweat evaporates, it carries heat away with it, allowing us to continue moving for hours, even under a hot sun. Most large mammals rely primarily on panting to shed excess heat, a system that becomes increasingly ineffective the longer they are forced to run. Eventually, the animal faces an impossible choice: stop and overheat, or keep running until its body begins to fail. This strategy, known as persistence hunting, exploited one of the few genuine physical advantages humans possessed. Hunting parties would track a single animal relentlessly, refusing to let it rest or recover. By the time exhaustion finally set in, the prey was no longer facing fresh, powerful hunters. It was confronting people who had patiently transformed its greatest strength into a fatal weakness. Against a full-grown mammoth, persistence hunting alone was rarely the entire answer. The sheer size of the animal made that an extraordinary challenge. More often, exhaustion became just one stage of a much larger plan. Hunters could drive an animal toward a waiting ambush, funnel it into a prepared trap, or force it into the path of a planted pike where its own momentum finished the job. None of these methods existed in isolation. They were layered together, adapted to the terrain, the prey, and the circumstances of each hunt. None of these methods worked because one hunter was exceptional. They worked because dozens of people became one coordinated machine. At first glance, it is tempting to think that the spear was the invention that changed everything, or the trap pit, or persistence hunting. Each was undeniably ingenious, but none of them explains the most remarkable part of the story. A spear doesn't brace itself against the ground. A trap doesn't lure a mammoth on its own. A herd doesn't conveniently run toward a cliff by accident. Every one of these strategies depended on something far more extraordinary than any weapon humans ever built. They depended on other humans. Imagine trying to hunt a mammoth alone. Even with the best spear ever carved, the odds would be hopeless. Now imagine 20 people who all understand exactly where they need to stand before the hunt even begins. Some quietly position themselves along a migration route hours in advance. Others remain hidden near the trap. A few carefully pressure the herd from behind without triggering a full stampede too early. The hunters holding planted pikes don't move at all until the precise moment the animal commits to its charge. Every person has a different task, yet every task serves the same plan. That kind of coordination requires something far more sophisticated than courage. It requires communication. Hunters had to share knowledge about migration routes, seasons, weather, and animal behavior. They needed enough trust to believe everyone else would be in the right place at exactly the right time, because a single mistake could turn a carefully planned hunt into a catastrophe. When your survival depends on another person's actions, cooperation stops being a social convenience. It becomes a biological necessity. Many anthropologists believe these demands may have helped shape the evolution of the human mind itself. Organizing dangerous hunts involving dozens of individuals requires memory, foresight, empathy, and the ability to understand what others know and intend. Some researchers even suggest that increasingly complex cooperation placed powerful evolutionary pressure on the development of language, allowing information to be shared with greater precision and passed intact from one generation to the next. If that idea is correct, then mammoths influenced human evolution in a way few people ever consider. They didn't simply provide meat, hides, bone, and ivory. The challenge of hunting such enormous animals may have rewarded groups that communicated more effectively, trusted one another more deeply, and planned further into the future than their rivals. Over thousands of generations, those advantages accumulated. Seen from that perspective, the greatest hunting weapon our ancestors ever possessed wasn't made of wood or stone. It was the ability to think together. Long before humans built monuments, wrote books, or founded civilizations, they had already mastered something arguably even more important, transforming dozens of separate individuals into a single intelligent system capable of solving problems that no person could ever overcome alone. That collective intelligence, not muscle, was the true force that allowed a small, physically fragile primate to become the most successful hunter the Ice Age had ever seen. There is one final part of this story that deserves equal attention, because success came at a cost. Every mammoth hunt was a calculated gamble. A planted pike could fail, a trap could collapse. A frightened animal weighing several tons needed only one misstep to crush or gore a hunter. No Ice Age records tell us how many people never returned home, but the danger must have been constant. These victories were earned with extraordinary courage and, almost certainly, frequent loss. Over time, another consequence emerged. By the end of the last Ice Age, mammoths, mastodons, giant ground sloths, and many other great mammals disappeared from much of the world. Scientists continue to debate the exact balance between rapid climate change and growing human hunting pressure, and the answer was likely a combination of both. But there is little doubt that humanity had become a powerful ecological force. The same intelligence that allowed our ancestors to survive one of Earth's harshest environments also gave them the ability to reshape it. The story of mammoth hunting is therefore more than a tale of survival. It is the beginning of humanity's long and complicated relationship with the natural world, one in which our greatest gift, our ability to solve problems together, could preserve life while simultaneously transforming the planet forever. In the end, ancient humans did not conquer the mammoth through greater strength. They conquered it by understanding the world around them. They harnessed physics by turning an animal's own momentum against itself. They transformed geography into a silent ally, using cliffs, valleys, and carefully built traps as weapons. They exploited biology through endurance, succeeding where faster predators could not. Above all, they relied on cooperation, weaving individual minds into a single, coordinated force capable of solving problems no lone hunter ever could. That same ability still defines us today. Every scientific discovery, every city, every civilization rests on knowledge accumulated and shared across generations. A mammoth never truly lost to one human standing with a spear. It lost to thousands of years of observation, innovation, and countless people learning to think and work together.